So this is a classic energy problem. The question is what happens to the energy as the ball is rolling down? In general, does anybody want to say, in general, what's going to happen to the potential energy, or in general, what's going to happen to the kinetic energy? So which one's going to decrease? Okay, she said the potential's going to decrease. That's correct. Anybody want to take a guess as to what this potential energy is right here? Anybody want to take a guess as to what that is? Yes. That is going to decrease down to...
Sorry to interrupt.
Hi Pat. I'm just recording a video for YouTube. It's no big deal. Just recording right now. That is 20. That's correct. That potential energy is going to be 10 joules right here. This potential energy is going to be 10 joules right here. And at the very bottom, the potential energy is 0 because it has no height. So you can see that the potential energy decreasing from 30 to 20 to 10 to 0. The kinetic energy here at the top is 0 because it's not moving. And that's an important piece of information in the beginning, telling you that the original velocity here is 0. Okay? So the kinetic energy is 0, therefore the total or mechanical energy is 30 joules. Now, the mechanical energy doesn't change unless there's friction, and we're going to assume there's no friction. Okay? Always assume no friction unless the problem says there is friction. Okay, so you can always assume no friction. If there's no friction, the mechanical energy, once you get that, you can fill in 30, 30, 30, all the way down. The mechanical energy stays the same. You learned about that law of physics in several different science classes up to this point. The kinetic energy right here at this position, the kinetic energy must be what? It has to be 10 right here because they're supposed to add up to 30. At this position, the kinetic energy must be what?
20.
Must be 20 because they have to add up to the mechanical energy. This is logic. There's not a formula for this. We're just using a concept and we're using logic. And at the last position, the kinetic energy has to be what? 30. We call this conservation of energy. This is the simpler version of the problem. Any questions?